So we're going to be talking about variables, functions. So because we're going to be working with math a majority of today, what you want to do is you want to go ahead over to VexCode. You'll notice that the developer already added a math.h file, but we need to add a bigger and more universal file. So just hashtag include, which is hashtag include is like the base way to include, like how we did it over here. We have a .h, we have this header file, robot config file. Hashtag includes kind of like the base way of including libraries and files. But so for this, we're going to do hashtag include. We're just going to add cmath, and we don't need a .h because it's kind of a universal library. It's just built in, just not added really.
Sorry, Sid.
Yeah.
Could you remind me of the undo?
Control
again?
Control
What
Z.
it is?
Control Z.
Control Z. Okay.
Yeah.
Thank you.
Yeah, no worries. So you just do that, and then you can go ahead and hit Control S, or just build. I don't have the build icon because I have a controller connected, but if I connect it, then I have the build icon. So I just press build, and then it builds. And then you'll see I have errors, but we discussed this last time. It's just because I have variables that I'm not using. So the program's basically like, okay, you should either be using them or just not have them. But it's not an issue as of right now. So we're gonna head over next to math.cpp, and then okay, so if you're trying to do trig, because eventually we are going to be doing a lot of, not a lot, but a good amount of trig and stuff like that, C math is going to become like a major aspect of what we're going to be doing, because we'll be using, some trig like sine, cosine. It won't be too complicated, but we will be using it. But for now, we just added it so it's there, but we might not even use it today at all. We might, it depends. But so just to quickly cover these 5 main variable types, you have an integer, give it a name, and it only holds integer values. So if you input like a 0.9, that's not 9. If you input, hold on, I realized what I just did. If you input like a 0.9, what that's going to do is that's going to just round, but the thing is it doesn't round down, it doesn't round up, it rounds down. So even if you have 5 point, like a bunch of 9s, if you try to use this number, it's just going to give you 50. So this only takes integers and it always rounds down in a sense. Float, it's another 4-bit or 4-byte variable. This takes a few decimals. I believe it's around 6 to 8 decimal accuracy, which is typically more than enough. You don't typically need more than that. Now, if you really want to be like hyper accurate, which in terms of Vex is kind of useless, then you can go ahead and use the 8-byte double. And this can hold, I think it was, I want to say 32 decimals. There's no need to be that accurate, even with pi. With pi, you can just use, so this is where CMath comes in, can help us. So we have this float declared as 0, but let's just go ahead and call it, we'll call it I can't spell imitation. We'll just call it fake pi. I'll go ahead and just put the CMath library has a pi constant, or it has a couple, but the main one is just capital M underscore pi. That's it. And again, the error is just you're not using it, but it's there. And it tells you float fake pi is equal to that whole decimal value right there. So that's that. But typically, if you're using pi, you don't want to make a whole variable for it. So if you're doing like, I don't know, let's say float circumference of let's just say circumference, and then you have, let's say instead of num1, you have diameter, which would be huge for 50 if that's in inches. You would just do that times pi. Now again, this is like, I made a variable, which I just said not to really, but like, if I'm doing like a function or something, instead of making this variable, I would just go ahead, copy this whole part in and paste it into that, but we'll get to that a little bit later. So doubles are just big floats, bools are booleans, which are just true or false, 0 or 1. 0 is false, 1 is true. And then strings are, so there is another one, which is a character data type. You're not really going to use that because it's kind of useless here. But a string is a bunch of character data types, and this can be like just extremely long, have anything in it. So I could just do this, like just randomly smash my keyboard. And then there are some neat little functions. So what I could do is I could do, instead of forward slash, if I do \n, it might not work because this is a variable, but typically what that does is that creates a new line. But I'm just going to go ahead and put in random string for now. And then this is something I wasn't planning on covering, but I thought would be pretty cool to cover, because this can, the more that I think about it, be useless or useful, not useless. It's called enumeration. Now, if you're taking CSA, I doubt you'll learn this, but if you do end up going into like data structures for computer science, you will cover this if you don't cover it before then. But an enumeration is basically custom creating a variable that can hold numbers and words, if that makes sense. So how it would work is we just say enum, and then we'll think of a name. So let's say we'll call it test underscore enum. And then we need a curly bracket, and then let's give it values of, oh, and this is a good example, up, down, left, right. And then we just add a semicolon. We can, if we want to declare it like this, where we have, it specifically be something, you would just add that name over here. So, variable ASD type test enum can hold these 4 values. But because I want to declare multiple instances, I'm just not going to do that. Oh, and I see I have a num1 error, so I'm just going to go ahead and rename dia back to num1. That should get rid of all our errors, yep. So now the cool thing about this is now, so hold on, first what I'm going to do is, if you notice, this is inside the while loop. So just kind of to not constantly call these variables, I'm just going to copy all of these and just move them outside of user control. It's not a big deal, but it helps the computer a little bit. So I guess we can also start some basic debugging as well here. So what we're going to do is to print to terminal, which is this right here. It's not like the official terminal, but it's the terminal for VexCode. The basic command is std : cout. Then you want 2 arrows going into that, and then you can just add your string. So we'll say output. Now, if I were to go ahead and run this, let me go ahead and download this into an actual robot. I can show you what would happen. That's the one downside about VexCode is if you want to test even just like debugging, you have to have a robot. Kind of hope they fix that soon, but as of now, that's not the case. So in a second, it should download. There we go. Now if I run it, there you go. So you're gonna notice that it is kind of slow, but it's just gonna be printing output constantly like this. And it's probably slow because of it's just constantly printing output, like just massive lines of it. But obviously, when you're trying to debug something, you can't read this. So one way to organize it is you can go ahead and add a \n, and what that should do is just end the line every single time. So I'm going to go ahead, clear terminal. If I run this, as you can see now it's running way faster because it's not trying to print like massive lines with the same word. And if you notice here, even though this output is literally just the same word, you can see that the line number is changing, which means that like every second it's printing output on a new line a few times a second. So go ahead, pause that. So we ran that for somehow exactly 1220 lines. And this becomes a little bit useful, but the main thing I wanted to show with this is, let's go ahead and make a test enum type variable. We're going to call it, oh no, we need to name it first. Let's go ahead and name it, what should I name it? Let's just say test output. And now you may notice that I'm also using like underscores here and like capital letters here. I'm just doing like a variation, so you can kind of get the idea that it doesn't really matter as long as you're following the basic naming rules, you're fine. And let's see, let's give it a value of up, right? So we just put in the value of up because that's one of the four. And then over here, let's go ahead and output test output. Now, when you have a string, the command to create a new line is /n, but we don't have a string, so we can't do that. So what we have to do is we have to do another double arrow, and then just do end L for end line. Now, we can, instead of end line, put quotations and put a string and do /n, but that's one more character than just doing end L. So this is kind of the faster way to do it if you don't have a string already. And the other thing, what we can do is to make this a little bit nicer is if we come up here, I already did it, but if under using namespace vex, if you go ahead on just add using namespace std, what that's going to let us do is down here, instead of std : cout, we can just do cout, and that is a little bit nicer. Not a massive change, but helpful. And what this is going to do is, if I go ahead, download and run this, in a second, it's just going to output 0. Now you might be like, okay, why is it outputting 0? Well, we haven't really covered arrays, and we might cover them eventually, probably will. But how this works is each of these has a value corresponding to, you can kind of think of how an array works. So how an array works is in an array, you set a size. So let's say you set it to size 10, but when you start actually inputting values, you're going to be starting at 0 instead of 1. So the very first spot would be spot number 0, and then 1, 2, 3, all the way to 9. So it has a size of 10, but you're counting one less in a sense. So in this case, up is actually equal to 0, down is equal to 1, left is equal to 2, right is equal to 3. Now, the cool thing about enums is I can go ahead and just say up is equal to 5. And if I download and run, what that's going to do is it's going to start outputting 5. Now, if I go ahead and change up to down, if I do that, it's going to start outputting 6 because it's just going to carry on by adding 1 to the previous value. Now, you can do some cool things with this because of that. And when we get to switches, this can also come in handy. But now I remember we were talking about the double colon and how, let me pull it up exactly. We were talking about the double colon, how it's accessing the correct variables when there's a name overload. And I didn't really have a good example for it, but when I was testing with this, turns out there is a good example. If I go ahead and put left in here and just leave it like that, you're going to see I have an error, and it's going to say a reference to left is ambiguous because, as it says, there's a left definition in main at line 36, which is our enum. That's this definition. Then it says in base.h, which is one of like the more hidden header files, there's something called left. And then in global.h, there's another variable called left. So there's three possible lefts, and the computer's like, okay, or the program's like, okay, which one do you want? Well, to specify that we want the one from enum, all we have to do is we just do test underscore enum double colon, and there you go. It's fixed. So now it knows to call left from test enum. And this is what I also meant when I said when you get into multiple libraries and stuff, you want to start using this specific line less and less because you want to make sure you're specifying the correct thing. So this is kind of an example of that. And it's one other
Hey
question.
Sid,
Yeah.
for COUT test output end L, I'm getting a problem. It says use of undeclared identifier end L. Did you mean std double colon end L?
Oh, did you
Why is that?
add did you add using namespace SD at the top?
No. Why do I have to?
You don't have to, but yeah, you're right. If you don't want to do that, you could just do std double colon and L.
Okay, but I have to put using namespace, right?
So there's two ways to do it. The way I did it, so the way I'm doing it right now is with using namespace. Now let's say this line didn't exist, which is what's happening in your case, you didn't add that. What you can do is, as long as you have std double colon in front of cout and std double colon in front of endl, it should work.
Yeah, I just forgot to do that.
All right, so yeah.
Up on top. Thank you.
Yeah, no worries. Yeah. So yeah, this was, I hope this, if anyone was still kind of confused on my explanation of double colons or didn't understand like why in some cases you use double colons, this was like a really good example of why. But now, as I talked about, you can, make this 5, this will be 6. Well, I can go ahead and just make this 100, for example, like in the middle of enum. And if you want, you can just, make each of them their own unique value. It doesn't matter. So let's say I do that. Download. I'm going to go ahead and clear terminal because we have 700 lines. There we go. And it should start outputting 100, which it does because that's what the left from test enum is equal to. So now we also covered if statements last time. So what we can do with this is we can do some, let's say, relatively interesting stuff. So there's two ways to make a function. For now, we're just going to make it always on top because as I explained last time, in most languages it's top down. So as in whatever you code at the top is only going to apply to lines below it. So over here, let's call, so functions have different types. The most basic type is void. And then you just give it a name, so we'll call it first function. And then an empty parentheses and then curly brackets. Now this is like the most basic format of a function. Void means there's going to be no output. I'll get to what that means a little bit in a second. And empty parentheses means there's no input. So what this will do is, let's say we have, I don't know, we'll just say cout inside function. So every time we call this function, it's just going to output to the terminal the line inside a function, and then it's going to enter one. So what we can do is we can go ahead and call that right here. So how you're going to call that is you're just going to take the name, the parentheses, and then semicolon. That's it. Now I'm going to go ahead and comment out this. Now remember, to do multi-line comment, it's just / asterisk, and then at the end of it, you just do asterisk / I mean, I only did 2 lines. I could have just done double slashes for single line comments, but if you're doing something like this, don't remember exactly why I had. Oh, this was when we were doing if statements, but yeah, see multi-line comment. And then if I just go ahead, download and run this, what's gonna happen is you're gonna see terminal blowing up, and it's just gonna keep saying inside function because that's where it is. Because this function gets called, then it knows that this exists, so it's gonna be like, okay, let's do whatever's inside of this. Well, what's inside? It's this output, which literally just says inside. Now, there's other types. So there's an int type, and you'll see we're getting an error at this, and it's like, okay, we didn't really change anything but the type. Why are we getting an error? Well, it says control reaches end of a non-void function, which basically means because it's not void, we have to be outputting something. So to output something, you just say return. And if you have a variable, you can put the variable name in here, but we don't. So we can either put in like a random number, or we can put in 0 for false or 1, but we just have to return something, some numerical value. So I'm going to put 0. So how you have int, you can also have float. You can have, what else was there? Bool, except in the case of bool, you see we're not getting an error even though we have a number value. But you also have to remember that for booleans, 0 is equal to false. So this would output false. And then you also have double. So we're going to leave this as int. And we're going to start talking about inputs. So when you have a function, you can actually give it an input so it actually does something with the value, or something with a value. So you can't, so let's say we want to do, let's do a square function. So we'll say square num for square number, and we'll take in an integer. We'll call that input. And then we want to return input. So what this is going to do is going to take a number, input. It's going to first print to the terminal that we're inside of a function, and then wherever this is called, it's going to return input. So if it's returning input, it has to be contained by something, which basically means we need another integer variable. So what we just have to do is come in here, we do int temp var. That's all I'm calling it because it's temporary variable. And that's just going to be equal to square num. And you see we need to add an input. So let's go ahead and give it an input of, let's do 5. Unused, yeah, we understand that, but just give it a cout temp var. And what's basically going to happen is it's constantly going to be scoring the number 5 and outputting 25 over here. But we haven't actually done anything with math-wise, we just said square it. So to do the math, there's 2 ways to do it. The first way is you literally just say input. Now you can make a temporary variable, but there's not really much of a point in doing that when you can kind of override or play with the input variable. So we're going to say input is equal to input times input. So that basically means it's going to say, okay, we're going to take input multiplied by input, which is 5 times 5, which is 25, and then we're going to store that value into input. So if input was 5, I want input to now be 25. So that's one way to do it. The other way to do it is we do asterisk equals input. So what this does is this kind of skips the whole input times input step, and it just says take the value of input, multiply it by input, and then store it back in input. It's just a shorter way of writing the same thing we just had. So like this, and that's plus, and this, these two do the exact same thing. Just you might want to use this sometimes because it's shorter and a little bit faster. So yeah, if I go ahead and download, and then I'll clear the terminal once that lets me. If I run this, it should just be outputting 25, which it is. So we just built a function that just squares itself. Now, we can use the math library. So I believe how that's going to work out is it's going to be, I actually haven't done this in a minute, so let's see if I got this right first try. How that should be is input is, let's say, POW. Yeah, okay, so I'm right. POW, and you'll see there's this POW, then there's this one, then there's this one, then there's this one. You'll notice this one says long double. Long double is if you took double, which is already huge, and decided that you wanted more decimal places or just a bigger number. I highly suggest you don't use that, especially for the level of robotics we're at, because there's literally no point in using a long double. And yes, there are things as I think it was long double, which is just even longer, but again, there's no point. Now we don't need to get into the specific ones over here. We can just use the first one or the variation of the first one, which is with the floats, which is this third one. But if we just ignore all of that, we just do pow, and let's say we have input, comma, 2. And basically what this does is pow, power of, you can think of it as a different function that we're calling that's in the math library, in the C math library. So what it's doing is it's taking the inputs of input and 2, and it's doing input to the power of 2, and it's returning that value to input. So hold on, this might make a little bit more sense if I actually make a temporary variable. So just put temp var in here. So we have a temporary variable, it's equal to nothing, like literally nothing. It's not equal to 0, it's not equal to 1, it's just equal to nothing. And what's happening is we're taking input, which is 5, we're putting it to the power of 2, makes it 25, and this returns 25, which means it puts 25 into this variable. So that means at this line, temp var is equal to input squared, or 25. So if we do it this way, it kind of loads relatively quick. We're going to get, oh, what happened here? Why is it not squaring? That's interesting. Hold on, I'll make this 2. I'm slightly confused as to why it's not working. Hold on. Alright, I have no clue why that's not working, because I've done this before. I'll figure that out, but yeah, that's typically how you would use like the C math library, for example, to do other math stuff. So instead of writing a whole squared function, you can just go ahead and use pow, because this way you can just do to the power of anything. It doesn't even matter.
Wait, so what does the thing we wrote right now do?
This power or square num?
Both of them.
Okay, so square num is a function that we wrote, and what it does is it takes an input called input and it squares it. So the two ways that we've discussed it so far is it does it by just doing, so hold on, let me rename this to temp var. Temp var. What it does is it takes the input and it multiplies it by itself. And the other way it does it is this is the short form way of doing this. It's the same thing. So these two lines of code are the same thing. It's just taking the input, multiplying it by itself, and then telling the same variable, okay, forget what you were just equal to, you're now equal to this new value. So input comes in, so one way to think of math in this sense is always do the right side of the equal sign first, and then go to the left. So how this is going to work is, let's go to the right side. We have input times input, so input times input is 5 times 5, because that's the example we're using. So now we have a value of 25 on this side. And then even though input has a value of 5, this equal sign is telling it, okay, forget about that you're equal to 5. It doesn't matter anymore. You're now equal to 25, because that's what this is equal to. And then this right here is just a short form way of doing this. And not entirely sure why this isn't working, because I also just searched it up and I should be following the format correctly. The only thing I can think of is doing this. Hold on. No, but that shouldn't matter because these are integers. Let's see, if I make this float, and if I go ahead and do this, this might work. Now what I'm doing might not make any sense unless you know what I'm doing. but if this works, I'll explain it. Nope, okay, yeah, so I have no clue why there's an error and why this isn't working at all, because this shouldn't even be doing this. That's weird.
And how are you getting things on your terminal? Like,
That's what
I'm not
cout
getting
does.
anything.
Oh, okay, so the reason you're not getting anything, and this was the thing I was talking about, which is kind of annoying with VexCode, is if you don't have a robot that you're connected to, the most you can do is build, which will give you like syntax errors, which syntax errors are like you just coded something wrong, like you forgot a semicolon. And then you have runtime errors, which is when the code's actually running, it's like, okay, hold on. Even though you coded it correctly, I can't do this math. And that could be something like you have a variable that's equal to nothing, and you're saying, do this variable times a different variable. Well, then you're going to get runtime error because it's going to be like, hold on, I can't do nothing times 5. That doesn't work. But the only way to actually run any of this code is to be connected to a robot, which is what sucks about VexCode. I have a
Oh, okay.
yeah, I have a coding bot that I use for coding specifically, so that's why I can run in terminal. I'll look into the issue as to why this isn't working entirely. Um, I might just be using a wrong output because there's different ways to output stuff. I'm thinking that might be it, but I'm not entirely sure. So for now, just this is a way to do it, but we're kind of just going to ignore that for now. We're going to go with like the class, or not the classic, but the simplified version of the classic way to square something, which is times equals. So yeah, we can do other stuff. So let's say we have, I'm going to go ahead and make this an int again. And I'm going to comment this out because I don't want mass amounts of quote unquote errors. Let's say we want to do division now. So for division, I'm just going to use float because even if we're using integers, if we're dividing weird numbers, then that's kind of you want the decimals. But now here's the thing: when you're dividing, it's not like a square. It's not like when you're squaring where you know you're going to be doing something to the power of 2. When you're dividing, you need 2 numbers. So to do that, what we can do is we'll just call it dividing. And we'll take in 2 integer inputs. So we'll take an integer of input 1 and an integer of input 2. And again, we're going to get an error because we're not returning anything. So we'll just say return answer. And then we have an error because we don't have a variable answer. So we'll say float answer. And now let's say that what this function does is it takes input 1 divides by input 2. Well, instead of making a third line in the function, we can just say answer is equal to input 1, and division is just a / for dividing, so divided by input 2. So what this does is when you call this function, you're gonna give it two numbers inputs, and you're gonna say, okay, let's say I want to do, we'll come down here, and let's say I want to do, let's do cout. Now I can call the function here, so I can do dividing. Oh, that's more than I wanted to erase. Now let's say we want to do 4 divided by, let's say 3. I hope this works. If it doesn't work, I'll be kind of annoyed because I don't want to go over the other types of output. It's outputting 1s and 2 5s. The 2 5 is because of this, and I'm assuming what's happening here is it's doing, it's getting, what is that like? It's getting 1 and 1/3, but then what it's doing is just it's converting it to an integer and just rounding it down. That's all that's happening here. So if we were to go ahead and put a 2 in here, this should work. That's the one annoying thing about printing out stuff. Yeah, so we have 2 and 25. If you're not printing on an integer, if you're printing on a float or something, you have to specify. But I don't want to cover that specifically right now. So we're going to stick to mostly integer answers.
But what does COUT and end-L mean? Or what are they used for?
So COUT is basically cout, which is C is the kind of like the base language of C++, and out literally means output. So COUT with the lines going towards it means output whatever's after it. And then the endl is just end line. So that means move on to the next line. Kind of like pressing enter when you're typing.
Okay.
Yeah. So yeah, so this is how I do some functions, some simple-ish math, I'll say. And then we have our main variable types here. Now, I think the last thing we can do real quick is we can go ahead and start a small motion profile. So what a motion profile is when you're doing autonomous or something or the other, or even when you're just driving, you want to be able to control acceleration or velocity, one or the other, you choose. Typically, we're going to be working with velocity just because it's considerably easier. I mean, we can do acceleration, but at this point, given that you don't have robots, it'll be easier to do velocity. And it's where you control velocity. So instead of like, let's say you're in driver, you have a joystick which has values from negative 100 to 100%. But with what you can do with the motion profile is you can say, okay, when the joystick's at 50%, so when the joystick value is reading 50, instead of running forward at 50%, we can run forward at 75% or at 35%. So it's just a way of controlling the throttle in a sense. So to do that, let's go ahead and we'll say float, say user speed. So speed during user control. And we'll take an input of, let's say, well, I hope this works because it's cool. Controller, and we'll say, ooh, that's not a good way to do it. Let's just say float, controller output. We'll say that, and then return. We'll say adjusted speed, and then up here we'll just call a float variable because it's speed. And the other thing this allows us to do is it will be a little bit more accurate with our joysticks, which is always good. So now, let's see. Let's do a little bit of everything. So if you don't mind, I'm gonna go ahead and let's do this. So adjusted speed is equal to, let's take controller output. Now, Daniel, give me a mathematical operation.
Subtraction.
Okay, so subtraction. Now I want Dachi. Did I pronounce that right? If you could speak, maybe. All right, I guess not. Chris, maybe. Chris, yeah. All
What?
right. What do you want? What do you want to subtract from controller output?
Any number?
Yeah, any number.
5.
All right, 5. And then let's see. We have Brady. Brady, what operation do you want to do?
Addition.
All right. And then Aiden, what number do you want to add?
Would do work?
Sorry.
Did that go through?
I'm sorry, I didn't hear what number you had said.
2?
2. All right. And then Akash, I need you to give me another operator, assuming you can speak. All right, I'm gonna take those as a no. So what I'm gonna do is I'm just gonna go ahead and in that case multiply it by, let's say 0.5. So now what's gonna happen is let's come down here because we want to actually use this. So what I'm gonna do is I'm gonna go ahead and comment out all of this stuff as well. And I'll get rid of this because this was from an example a long time ago. Now, let's create a variable, another float variable. We'll call it float motor speed. And we're going to say that's equal to, let's call the function. So we're going to say user speed. And let's give it an input. So we'll give it an input of, or how about this? We'll say motor speed left, so L. And then we'll give it an input of master.axis. Now, what are we using? We have axis 3 for the left side, so we'll just say axis 3 dot value. And then just add semicolon at the end. And then we're going to do the same thing for the right side. So motor speed R is equal to master axis 2, so user speed. And we're going to input master dot axis dot or 2 dot value. There we go. Now what this is going to do is it's going to take, let's say for this top example, right? It's going to take master dot axis 3 dot value. Then it's going to come up here and it's going to be like, okay, that's the input. Now, so hold on, I'm going to make this a little bit shorter. Just do that. It's going to take this input and it's going to be like, okay, let's subtract 5 from it. Let's add 2. And then let's multiply by 0.5. So PEMDAS doesn't entirely apply. It might in some cases because for this, especially because this isn't pure C++, it's kind of modified. But typically PEMDAS, in my experience at least, sometimes works, sometimes doesn't. So you kind of just have to test with it. But yeah, so you might notice that one weird thing that's gonna happen is, okay, hold on, so let's use this first. So let's go over here and we'll do, I'm actually not gonna put that here because otherwise my robot's just gonna like go somewhere. What I'm gonna do is I'm gonna go ahead and do a, see how it's not working. So maybe I'll just do it here. Yeah, okay, I'll just do it here and I'll hold my robot. So we'll do, come on, motor speed L, and just copy paste that into the speed over here. And then I can do the same thing here, but just make it right instead of left. That sucks. There we go. So before I run this, I'm gonna go ahead and grab the robot so it's not, because unless you notice it now, this robot's actually gonna start moving even if I'm not pushing the joysticks. And you might be able to hear it because it's actually near my face right now. So download, and if I run it, okay, so maybe, okay, so I think I might know why. Let me just check. Slightly odd. Hold on. If I go ahead and do this, oh wait a second. Hold on. I don't think my robots.
Wait, do we need to put them in different axles? Each motor?
What do you mean?
Well, yeah, because for left front motor and left back motor, you had like different axes on each one, right?
Well, each are on a different axle, but the thing is, because they're each controlling the same side, you want them moving at the same speed. If that makes sense.
Oh, okay.
Yeah. Now, but this is for a basic tank drive. What we've coded. Now, if you have been to a few of Andrew's CAD lessons, I think he coded an X drive. For an X drive, instead of one axis input, X drives actually need at least 3. So in that case, you don't want each side, running always exactly the same, unless you do, which it still works, but you don't always want it to be that way. So in that case, yeah, your concern is valid. Here it's valid still, but you don't need the same side to have motors running at different speeds, because that could lead to a lot of just skipping and just scraping, and you don't really want that because that's against accuracy in a sense. So really quickly, I'm gonna go ahead and put these in the correct ports, and it should work. Let's see. What is this? This is left front 7 6. So this should be 7. And why did that just happen? Hold on. 7. And then this should be 6. And then this should be. You don't have to fix this. I'm just doing this so I can get this thing to run real quick, just so maybe you guys can hear what I'm doing, like when it starts running. 17, and this should be 16. These shouldn't matter. Actually, this would matter. Let's just say that is 20 or 9. So not using 9. Hit download, and this should work because I don't see any other errors. So you can't hear it. Maybe if I put my mic really close to it. No, barely. But basically, what's happening right now is even though I'm not touching the joysticks, the motors all of them are turning extremely slowly. And the reason is, if we come over here and we actually look at what we did, where is it? Here. So we're going to see, okay, motor speed left is equal to the value of joystick axis 3. Well, okay, if I'm not touching it, that's equal to 0. So come over here, we have 0. Adjusted speed is equal to 0 minus 5. So that means we're now at negative 3 plus 2, which means we're now at, hold on, 0 minus 5 is a negative 5. I don't know how I got negative 3. So we're at negative 5 plus 2 is negative 3 times 0.5. Well, it's a float, so that's going to be negative 1.5. So because of that, all 4 motors right now, even though I'm not inputting anything, is spinning at negative 1.5%.
Wait, you said it follows PEMDAS?
Typically it doesn't. I can double check really fast right now.
Does it go from left to right then?
Yeah.
Automatically?
Yep. Hold on, I'm just checking something. If I go ahead and change, let me just confirm if it does or not, because I want to make sure. I'm just going to make these all RPM rather than percent. You don't have to. I'm going to change it back after. I'm just doing this so I can tell you exactly what is going on. Boom, boom, boom. And if I run it, they're spinning. And if I look at the brain, RPM, so okay, so these are following PEMDAS. Okay, so that's nice to know. So what's happening here is we have an input of 0, so 0, coming up here, and then we have to do multiplication first because that's PEMDAS. So 2 times 0.5 or 2 times a half is just 1. So this right here is 1. Then you have 0 minus 5, which is negative 4, plus 1, or God, 0 minus 5, which is negative 5, plus 1, which is negative 4. So now you're getting an output value of negative 4. And because I have them in terms of RPM, what the motors are doing is they're all spinning at negative 4 RPM. Which would mean, because even though I put forward here, that just means they're spinning in reverse at 4 RPM. So PEMDAS is followed. Okay, that's nice to know. Typically, I use parentheses liberally. So how I would probably have done this would have been like parenthesis here and then over here if I want to do addition first. So I didn't exactly run into the PEMDAS problem till you mentioned it, but yeah. And the other thing is right now, all the motors are spinning in reverse of each other, so the robot's actually going nowhere even though I just put it on the floor. So yeah, this is this is like a super simple motion profile for velocity. And I say simple because we're just doing addition, subtraction, multiplication, division. Let me see if I can pull up an example really quickly of a motion profile that I made, I think 1 or 2 years ago. So you can kind of get an idea of what you can do with all of like the math, the C math and all that stuff. Let's see, graphing calculator. I did it on Desmos as well, which is the funny thing. Let's see, can you see Desmos on my screen right now? Possibly, maybe.
Yeah, we can see it.
All right. So what I was trying to do was, at the time, I think we had just finished in Calc BC learning about logistic functions. So if you recognize this as logistic function, that's exactly why. That's what it is. And when we were driving, our robot was actually a little bit too fast for us to control because the game that we used this in, which was Tower Takeover, you needed a good amount of accuracy because the whole point of it was just to pick up as many cubes as you can. So the thing was, when we're lining up, we want it to be a little bit slower, but then when we're scoring, we want it to be, or when we're just driving around super fast, we want it to be faster. So if I go ahead and figure out which lines to delete or hide, so hold on. Yeah, okay. So this is the basic, not the basic, but this is basically what it looks like. So when you're at a value of 0, for mostly autonomous, when you're at an error of 0, your speed is going to be hard set to 0 by like if statements. But the reason it's at like 20 right here is because if you have a value of 0.1, we want it to be as close to 20 as possible because 20% is like a good spot to like be slow enough that you're moving, but not so fast that you're messing up or anything, or your robot's like doing a wheelie. So it starts at 20%, and if I pull up the linear graph, you'll see that if I was doing this linearly, we would be hitting close. We would be hitting 100% around, what is this, the 80 mark. But what I did was I split it up into a bigger range so that 100%, 100%, you're going to be close to 100, but you're not going to be there, but it's close enough. And this way you get like a whole 20, you get a whole 20 unit range of what to do. As you can see, it kind of follows the linear graph and then it gradually speeds up before slowing down at the top end. So we mostly use it for autonomous. Now you can use this for driver control and stuff like that. And how you would do this is you would do stuff like, for this, for example, you would say, take the input, which would be x, and you would say, do 100 divided by, okay, parenthesis, 1 plus e, and then you would use a power function. So you would say e comma this bit, and then you would say input minus this bit, and then you would make that equal to your adjusted value, and then your adjusted value would be output to the motors. So when we get into like hardcore autonomous and stuff like that, then we're probably going to start using a little bit more complicated motion profiles, maybe not something this complicated. You also might be wondering where I got these values from. I basically just wrote a program that would kind of just optimize numbers based off of inputs. So like, I think I was testing with the error of 100 units. And how it would work is it would say, okay, at the first iteration, you have an error of 100. And at the second iteration, you have an error of 99 all the way down to 0. And basically based off of that, I would get these constants, which even though they seemingly appear random, they were calculated by a program. So, but yeah, don't worry about all this stuff, complicated stuff. We'll get into more complicated motion profiles, but unless you want to go out of your way to do this, I don't think there's a need to do a logistic function entirely. But yeah, so just to recap on what we did today, we just retouched upon the 5 main types of variables. You have integers which only hold integers, float which hold like 16 decimals, doubles which hold like 32 decimal places, booleans which hold true or false, or 0 or 1, and strings which just hold a bunch of characters. And then you have enumerations, which is where you can make your own variable type and give the variable type a name. Like each variable value has a name, but it corresponds to a numerical value. And then we just talked about, some relatively simple mathematical operations like multiplication, subtraction, division, addition. And then we talked about functions. So you have the basic void type. As you can see, user control is a void type. And then you can make custom types. So you can say, you can have outputs of integer, float, double, all that fun stuff. Integer is up here, float, float. Or I could just make this double if I really wanted to. So yeah. Are there any questions before I kind of... So in that case, we go ahead and